We have all the components we need to make the perfect brisket: smoker, firewood, overpriced meat thermometer, and beverages of choice. Now all we need to do is master the smoker. When we do, what starts out as one of the toughest muscles on the cow turns into a little slice of heaven. As engineers, we thought, what is really happening inside the smoker? So we decided to design, validate, and showcase. Today's team: Wesley McMurtrey, an application engineer out of the Tulsa, Oklahoma office; Kyle Dyer, an account manager out of the Tulsa, Oklahoma office; Dina Love, a marketing specialist; myself, I'm David Cersley, an AE out of the Austin, Texas office. Welcome to Straight Grilling, SOLIDWORKS CAM, Visualize, Weldments, and more. Who we are: we are GoEngineer, a growing company, where 40% of our nearly 300 employees are certified technical specialists. Who do we serve? We serve you, the customer. 2/3 of our customers employ 50 people or less, and a quarter of our organizations employ less than 5 people. We are here, and we're growing because of you. We have 25 offices across 14 states. Goals for today's webinar: design intent. Our first goal is to design an offset smoker using SOLIDWORKS sheet metal and weldments. We will create a multi-body part design, turn it into an assembly, and finally run a design study on the smoker. Validation of the design. We have to validate the design of the smoker. We will take an in-depth look at SOLIDWORKS flow simulation to help understand how this flow of air affects the cooking temperatures. This will lead us to the question: can we improve our design? Can we improve the design? We will go back into SOLIDWORKS and see if there are any modifications that we can make that will allow us to make a more efficient cooking smoker. If we do make these changes, can we validate it against the original design before we cut any parts? Do the modifications work? We will go back into simulation to evaluate the design changes. Then compare these results against the original. Once we have that done, we will be ready to cut some parts. CAM. Wes will take his years of experience and show us how we can take SOLIDWORKS CAM to get our design from screen to first article parts. He will show us how to cut a part with patterns and run the setup for a plasma cutter. Lastly, Wes will take a part off the smoker and show us how to generate toolpaths and how easy it is to use SOLIDWORKS CAM. Visualize. Once we have our design finalized and validated, we will use the firepower of Visualize to take our design from model to a photorealistic image. So sit back, relax. The brisket will be ready shortly. Let's talk about grills and smokers. When cooking a brisket, one of the key elements is making sure that you have a solid method for maintaining temperature. If you're smoking your brisket, say at 250 degrees, your temp range should be, at a low of 225 and a max of 275, kind of in that window. So knowing your smoker and how to maintain temp is critical on cooking briskets. When it comes to ceramic smokers, these are very thick-walled ceramic material design, super efficient, requires little effort to maintain that constant cooking temperature. In this one, the fire is below and it pushes the heat in upward and through the grill. On an offset smoker, this design has the firebox offset from the cooking chamber. With the offset, there are two styles of smokers. One is a traditional where the smokestack or the exhaust is opposite ended of the firebox. A reverse offset smoker, the smokestack is actually over close to the firebox, and what happens here is there's some internal baffles, so the heat kind of goes to the far end and loops back over on the top of the grate. This model is often referred to as the pill. Easy to use grill on top and a very compact design. Again, the heat's going to come up from the bottom through your meat. Barrel smokers, much like the pill and the ceramic, the heat's going to come from the bottom. These are becoming more popular and they're easy to use. You can actually make your own pretty easily with just a couple grates and a 55-gallon drum. Cut a couple holes in it and you're off to the races. An electronic pellet smoker, super popular right now. Easy to use, just kind of set the temperature, add some wooden pellets, and there's an auger that actually pulls the wooden chips into the cooking chamber, and it drops the pellets off into a little firebox, and there's a fan that blows the smoke and allows the air to permeate around in the cooking chamber. The electric smoker, this is an easy to use as well. The difference is on the pellet smoker we just looked at, those pellets are using an auger to pull it through. These use an auger, but they're usually over a heating element in some of the designs. So the heating element kind of heats this disc up, not the pellets. Today, what we're going to focus on is the offset smoker design. So let's get to designing our smoker. So let's get into the design. Give me 1 second to switch screens here. Can everyone see this screen? Wes, can you see that?
Yep, you're good.
Okay, cool. So this is our smoker that we've designed. And it's just a single offset smoker. Again, the fire chamber cooking or firebox is offset a little lower than the main cooking chamber. And to create this part, this is done as a multi-body part. If you look over here on my surface bodies, I've got 6 surface bodies, but in my cut list, I have 77. That includes all my weldments for my legs and tables. And I made it so that if I adjust the firebox or adjust the legs, the cooking chamber itself updates. And that was one of the goals. If we change it, we want the weldments to update. So we associated the weldments in the frame to the firebox. And I'll try and show that here in just a second. So let me roll back a little bit and we'll talk about the design intent. We'll talk about how we created this guy. So I'm going to go back and talk about the main cooking chamber. So we started out with a common method for making smokers here in the Austin, Central Texas area, and probably nationally as well, is to take the propane tank design where they're domed on the end and create a smoker from it. So in this case, I went in and looked at some of the measurements for the gallons of the propane tanks that are currently being used. I went to the local sporting goods stores and visited several barbecue pits masters here in town and looked at their pits, and they were like, yeah, this is kind of an average size. If I click on it, we got all our dimensions, and this got about a diameter of 30 inches on it. Okay, and so said okay. So once it created this chamber, I lopped off the right side. From there, it was getting into the science of, hey, I need to create a smokestack. There are several methods to doing this. We could have pulled this out more like a chimney and an L bracket and reduced it down. There is some science between the smokestack size. The bigger the smokestack, the more air we're going to draw across our cooking grate. We haven't put the cooking grates in. And then there's also some science between the opening and the closing of the dampener. Now we're going to run simulation on our part with several configurations with the damper 15 degrees open, 30 degrees open, 60 open, and then what we call fully open. In other words, the end cap here is wide open. I've just got it pouring out. And so we'll go from there. We'll talk about that. Again, what we're trying to do is draw the air through the chamber and out of the stack. The height of the stack seems to matter as well. The higher the stack, there is a range where if this is too short, the flow of air is just rushing across. If we get it too tall, the air is kind of slowing down and stalling in the smokestack. And then there seems to be a height right around here. And I think we made this one around 36 inches high. It seems to be pulling correctly for our sim products. Next, we went through making the main cooker door. So just simply punched a hole in it, made my door, made our hinges, so that our handle, put a little simple rod in here and just made some simple hinges. Hopefully I'm not making you too car sick by rotating this around. If I am, a Wesley, just let me know, or somebody jump in the chat room, hey, you're making us car sick.
I'm getting
so there's our door. And you know,
no, you're fine, Dave. You keep rotating that thing. So
now you're getting car sick. You really want barbecue, right? And then so we went ahead and I did one little feature. I put our company logo on the door. So now we got GoEngineer on the door, and Wes is going to show you some really cool ways here in just a little bit how to kind of accentuate the branding. Right now it's kind of I don't want to say bland, boring, but it's a little bland, right? Just kind of I did a plane that's sitting off of this surface, created the logo and extruded it up to that surface off that plane. And it gave it kind of a cool little look, as opposed, we sure could have done the wrap feature. Here, I just thought this kind of gave it a little cooler look. So, you know, me being a little bit nerdy, kind of liked it and went forward with it. The next thing that we did was put in the main cooker grate. So I'm going to let that open up. That takes just a little bit because there's quite a pattern to it. I'm going to section view this guy. Let me reverse that section view. So I'm going to reverse the section and we'll talk about the cooking grate. So inside of our cooking chamber, it's acting a little slow. Give me 1 second. So we have our cooking grate here. And we associated it right at the mid plane, kind of going through the middle of our tank. And there's our grate. And we put it on a rail system. So if I open the door, I can grab the two handles, slide my grate out until it hits a register. Can't go any further out and fly on the ground. But if I want to wrap my briskets, I can. And that kind of gets into the Texas crutch, as we call it locally. It may be called something different in Tulsa and the Oklahoma region. But we call it the Texas crutch. And that's when if you're smoking a brisket, it's cooking along nicely, your thermometer's going along, and you get about to the 4-hour mark, and all of a sudden your temperature stalls at about, I don't know, about 160, 170 degrees, and it can stay there for a couple hours. And it'll stay there because the toughness and the internal tendons of that brisket are trying to break down. And one way you can kind of accelerate and get through that is by wrapping it. Franklin's has made the butcher paper popular down here. Some folks wrap them in aluminum foil. There's no wrong way as long as you get a great product. And then there's some people that just leave it on there. And so now we have our cooking grate designed in. The next thing I did was create the firebox. So for the firebox, we created an offset where the top was right at this position here. And I want to do a little section view here so we can talk a little bit about the smoker box design, because there's quite a bit of science that goes into these guys. So the firebox itself, we did a double-walled firebox. In other words, we have an inner diameter, this metal here. We have a fiberglass ceramic, a ceramic insulated wrap here. And this wrap can be purchased at like Grainger and several other places. If you just look for like ceramic insulation, it'll come in a roll. It's a little expensive, nothing too crazy, but we figured out the thickness and then wrapped the firebox. And then we wrapped it again in another sheet of metal. And our metal on this guy is, hold on 1 second, I can tell you. I set my wall thicknesses to 1/4 inch steel. I couldn't remember if I did 3/8 or 1/4. And so when I was designing these plates and it asked for a thickness, I would just do the global variable equal to, and the thickness, and then all the metal in here is set to 1/4 inch thick. So we have a double wall. Why do we double wall it? Because what we don't want is we don't want the heat to escape through the single chamber. We want to insulate this chamber as much as possible. Now you might be looking at this going, well, Dave, if you're trying to control the heat, why didn't you control and double wall the firebox? When we get into simulation, I'll show you why we didn't do it. Could we do it? We absolutely could. I want to show you when we look at the heat loss on this guy, where the heat's actually going and why this double wall is super important. Now, some folks will make the inner wall circular, wrap this around, and then they'll do the outer wrap in a square shape. They'll put fire bricks all the way around. Either way works. Again, what we're trying to do is insulate this so that the heat isn't going through the metal. It's actually going into the cooking chamber. We're trying to cook the meat in the chamber. I'll undo this section view. And then the last thing we did, two more things here, or three. We went ahead and created the door. Now, in a little bit, Wes is going to show you the door. We created the hinges, created the door. put our corporate logo, put some vents so that we can pull air through the system. And we did something kind of fun. I haven't seen this before, but we thought it'd be kind of cool. If you've ever smoked a brisket, you know that you're out there for an extended period of time where you've got a family barbecue going on. So we made a little the door latch is actually a GoEngineer logo door latch with a beer bottle opener. Oh, I'm sorry, bottle opener. Don't want to endorse beer here. But a beverage of your choice, you can actually have a bottle opener here on the door so you can open your bottles while you're out there smoking. Because if you've ever smoked a brisket, you know, hey, again, I'm out here 12 to 14 hours. I do get thirsty. I'm checking the fire temperature every couple, maybe every hour, depending on the wall thickness and the type of smoker. You might have to put wood on it every 30 minutes. Depending if it's super insulated, you might be putting wood on it every hour and a half. It just depends. The next thing that we did was we wanted to go in and create a frame using Weldments. So from here, I did a sketch and I did my Weldments. And when I did this Weldment frame, a couple things. I made sure that these legs stayed within so many inches of here, and then just did an extrusion up to this body. But what I found was SolidWorks didn't like the way I was trying to create it. So what I did was I did an offset surface of 0 here, so that there's just basically, I'm creating an offset of that surface. I then hid this upper body for the main cooking chamber and then trim cut these legs using that surface. Turned that surface off, and that's how I cut those legs on that circular surfaces. Did the same thing for the firebox. You may know a better way, but that was the way I knew at the moment when I was designing it. So if I change the firebox design, let's say I clicked on the firebox, and I'm gonna try and get this on the right angle where you can kind of see it. You can kind of see this leg here, this vertical leg here. So now if I change my firebox, I'm gonna drag this 28 up. If I grab it to 32, let it rebuild here for just a second, and we'll watch the legs grow with it. So all we did is we did some sketch relations, and we defined it and said, hey, from that edge to the center line of this rail, there's a dimension locating it for 8 inches. Let me go back. We'll set that back to where we were. And so the frame moves as we move our smoker. So we've got our design set up. Kind of our design intent was if I change the diameter of either one or I change the size, the weldment legs will go up. So now I've created a cooking chamber. And then the last thing we did, last two things, kind of small, but we went in and created holes for the thermometers on the right to the left. And what we noticed was that most smokers on the market or grills had a temperature gauge here in the center. On ours, being kind of nerdy engineers, we wanted to know what's the temperature on the right, what's the temperature in the middle, and what's the temperature over here on the left side of our cooker, right? So we wanted to monitor completely across the grate so we could see what's actually happening across the entire chamber. So maybe I've got some briskets. Maybe I need to cook 6 or 8 briskets and I pile them in here. What's the temperature on the right? Why is these ones on the right cooking differently than the ones in the middle or the left? Or maybe I need to cook some ham or some sausage or some ribs over here on the right because it's a little hotter, or I'm putting my briskets over here on the left. And we wanted to study the cook temperatures across here. The other thing that we did is I went ahead and created a little grate that the wood is going to sit on, and it's just about right at the top of my vent ports where the air is going to come in. So now I've got some fire. My logs are sitting up in the air. I'm drawing air under the logs. The charcoal or the little bit of chunks of the coals can fall through. I'm okay with that. I've got double insulation, but I've got ability to get air underneath the cooking grate so I can pull some air and continue the hotness. All right, so that was it. Now the question is, does this offset design smoker design work? All right, so I'm going to get out of here and I'm going to go over to my PowerPoint again. And Wes, will you confirm you can see my screen here now?
I can.
Okay, you can see the PowerPoint?
Yeah, I'm starting to get hungry now all of a sudden.
Pardon?
I'm starting to get hungry all of a sudden.
Man, I'm hungry too.
See
I
that
keep
big,
talking about barbecue. I need to go get some barbecue or make
Yeah.
some barbecue.
that big brisket.
So let's talk about simulation. And I want to tell everyone right up front. I'm not a simulation expert, but I know one. And I'm not going to play one today on TV. Shivani Patel out of our Houston office is our simulation expert. She ran these simulation studies and we worked very closely on what's actually happening here. Here was the initial study where we were looking at the airflow, kind of where's the airflow going through the firebox. And this is basically showing you the speed of the air going through the box. So it's pouring in kind of over on the grates on the right. And you'll notice here in the smokestack, the air is really accelerated going through that stack. So it's pulling some of that air up and across. And these lines are going to make some sense here in just a little bit. When we looked at this is the top-down section view of our cooker, right through the dead center. What we did is Shivani created a surface so that she could measure the temperature right across the cooking grate. What we found with the current designs is kind of interesting. The cooking temperature kind of going down the center was we have a hot spot right here up at the front. It makes sense. Our firebox is over here, right? We're at almost 340, I'm gonna call it 345. In the middle, we were quite a bit cooler, 278. And over here on this far kind of green temperature, you can see it's around 300. So the colors differentiate. If you look over on the left side of the screen, the dark blue is the 260 and the red is the 360 degrees that we're starting to see in our chamber. And it kind of brought us to something that we saw happening at some of the major barbecue places here in the local Central Texas area, is that a lot of people only use the back 2/3 of their smokers because this area is too hot. And we're like, well, wait a minute, you're not using that? And they're like, no, it's too hot. We usually don't cook on it. So what we do is we put water pans up there, or one company actually, before the firewood goes into the firebox, they'll actually go through an extra step of drying the wood on that first grate. And we're like, but you're losing revenue by not using that area. And they're like, yeah, but we don't know how to solve the problem. Aha. That was kind of one of our aha moments. So you can see again, this is a hot spot, almost the unusable area of the grill. And let's say we're going, this is the chamber, let's go, it's the left, the middle, and the right side. Most of the companies, if they have 4 to 5 chambers in these massive smokers, this first chamber is not utilized, other than holding water pans or maybe drying some wood. You can see here now we've got an uneven distribution of the heat. So how are we going to fix this? Let's walk through a couple more plots and let's take a look at what's going on. You can see here in our firebox, we talked about not insulating the door. If we were to insulate that door, I might only insulate the top half of that door, maybe above the door, but most of the heat is directly pushing up off the fire. We did quite a bit of research. We didn't know where to set the coal temperature, the wood temperature for this study. And today's example, we ran the temperature at 1500 degrees constant for the sim. What we saw was the air wanted to come up here, get very turbulent in the corners. It's pushing in a vertical direction. So in a weird way, our double walled insulation is working great. But look what's happening here as it comes into the chamber. It's that hot air is pushing right across the grate itself. And it's also staying up here in this pocket, and then it's pushing and then it's going out. And then the question was, can we fix that? And again, there's our hot spot as it rises across the firebox into the right side of the grill. Now, this is one of the coolest things I've seen in a long time. This is what they call an ISO plot. And so what we did here was Shivani ran the simulation, and ISO surfacing. When you run flow simulation, this will change. We can set the variables to show us certain degree temperature ranges, show that it'll automatically create these surfaces in the cooking chamber. In the image on the top, you can see basically the surfaces of the air that are being pushed in, and there's actually a little hollow spot right here, which is kind of interesting. So the air is coming up and it's pushing down, and the hot air is pushing up through that grate right here behind this handle. I'm kind of flashing the cursor. And then the hot air is sitting on the back right side. This is a top section view. This is the logs, and this is where the fire, looking straight down. You can see that the air is kind of sitting here, circulating before it kind of billows down around the right and the left. When we saw this, we were fascinated. And then when we talked to some of the pit masters here in town that run some of the bigger barbecue places, and they were like, oh, that explains why we can't use the front grate and why we have certain cooking zones that we only use in our smokers. And this channel, this just expands, causing the hot air channel on the grill. So let's look at a top-down view. Top left, top mid, and top right, we can see our temperature changes from the, this kind of a, if you've ever seen the movie Predator, this is kind of like how the Predator was looking at Arnold Schwarzenegger and all those guys, right? So kind of cool. And this is what the thermal looks like. This is what the temperatures were. Over on the right, we're looking at around 350, again, 350 some degrees, measured over the entire bulk area. The max temperature was 358, but the average across that area, imagine that whole square here, was 300.9 degrees. And as we moved across the chamber, this bulk area, again, everything kind of in this little quadrant, you can see that we're kind of 291, and then it actually went to 294, which is interesting. And this one's 291, 290, and then 303, but the whole thing is symmetrical, which was kind of unique to us. And we were like, what the heck is going on? Our max temps were pretty close, 305, 305, 357, 358. So we're pretty close there. So we learned that. So what can we do to fix it, right? I'm going to escape here and I get back into SOLIDWORKS. So now we're back into our design, right? Our design intent was to design a grill / smoker that we can utilize the entire cooking area. If we're trying to cook briskets, we're trying to cook them. Yeah, I know this gets picky, so don't get mad at me and start throwing tomatoes at the screen or whatever. Everybody has their own specific cooking temperature, and it's a wide delta. One cooking company here, one barbecue company here in Central Texas cooks their briskets at 225. There's one that cooks them at 400 degrees. The average is probably about 275, plus or minus 30 degrees. They're truly trying to hold that to about 25, but we'll say plus or minus 30. If you've ever smoked a brisket or smoked a pork shoulder, you know you're out there a while, and when you put the wood in, it first starts to burn, right? And what we're looking for when we're using these chambers is, obviously, we're looking for a clean smoke, not a dirty smoke. When you first put wood in, there's going to be this grayish plume coming out. And we want to use a clear smoke coming out the chimney. Almost looks like blue when it's coming out of the chimney. So good firewood and good design will help us get that nice cook across all of our briskets. So how are we going to do that? I'm going to go to a little section view here. And what we're going to do is, the first thing we're going to do is, and this was our first runs at it, is we added a baffle. So internally, what we did was we decided, hey, let's add an internal baffle. And the first study we ran, I just made this out of a sheet metal part that had a little flange on it, and we welded it to it. What we noticed was it was getting super hot right here on the metal, and then it was billowing around and pushing back. So actually what we did was we kind of created 3 little registers. I'll do my best to do this, zoom in a little bit, but we created like 3 little blocks and then welded this plate to it. You may have a better design, see something easier. Probably could have done just a flange and then cut some notches in it for sure, right? But we just did a plate like this. So now our theory was, we're going to get some plate in heat coming through these ports here. But the bulk of the heat's going to hit this plate and push down, and I can now cool and cook off this front area of the grate. The second thing that we wanted to do, I'm going to get out of this section view, was to turn in and add a damper assembly. All right, so I'm going to roll that down. There we go. My apologies. So we added a dampener assembly. So this damper is now in what we call a closed position. So when we ran the sim, we pulled the handle open 15 degrees, 30 degrees, 60 degrees, and then all the way open, where this is back to what it looked like pre-damper. In other words, wide open. There's no restrictions of the air across here. We wanted to see the effects of the dampeners across the temperature across the cooking area. So we're going to put the dampener in. We're going to create some configurations, and we're going to run a whole bunch of sim studies. All right, I'm going to get back out of SolidWorks. So we made some design improvements. Did it help us? Are we on the right path? Let's take a look. All right, Wes, can you see that again? PowerPoint?
Yeah, you're good.
All right, just checking.
You're cooking.
So, woohoo! No pun intended, right? Smoking. Sorry, I had to get some water. So let's take a look at now what's going on with our airflow study. Before, we had the air going up, and that red air was pushing across this area right here in our area. Boom, boom, boom. Look what's happening with the baffle. We're deflecting that heat. Okay? So let's get into the design and the analysis just a little bit further. This is what we did. We basically changed, if you're wanting to see what that change and what that baffle looks like, right now we have the initial design, or what I call design 2, with the kind of the slats in it that we talked about so some air can escape, is we've done this with a continuously solid circular shape. We are experimenting with different hole patterns, louvers, and the size of this maybe end up a different shape. Stay tuned. We'll have another one of these coming up soon. We'll keep you posted. But let's take a look at what's going on here now. We look at this guy with the baffle versus with no baffle. So over on the right, we've had an initial cooking temperature, and what we're going to call this is fully open. In other words, the dampener is pretend it doesn't exist yet. This is just the baffle. In other words, the dampener is wide open. We notice that the cooking chambers on the right have reduced their temperature from 345 to 301. That's awesome. We've lowered that 44 degrees. Now we can start cooking something a little bit better. We also lowered the chamber in the center 2 degrees, not a big difference. Over on the left, we lowered it by almost 10 degrees, 9 degrees. And so what we can start to see is some different change. So the baffle is working. The question is, what other designs can we do? Now, what happens if we have the baffle and we start to play around with the dampener and control the airflow? So we can see that we have significantly lower temperatures. We have a little more even distribution of the heat. And we have a little more even distribution that we saw over on the right. So the baffle is helping it to even out that temperature. Again, there's our little airflow study. Shows the hot air, the cool air, and how it's flowing through our smoker. The red is 360 degrees, and you can see how we've reduced it down quite a bit. Again, the time it takes to divert around the baffle lowers the air temperatures significantly. There's a little snapshot of no baffle versus baffle. The baffle works. Now we have to perfect the design. We're working on it. There's our sim plot now, or our ISO surface plot. Looks much better. Everything looks a little cleaner. Before we had some red that was way down here past the initial, I'm going to call this the hinge for the top of the door. And now we're controlling that a little bit better. A little bit of a more zoomed in view. You can see now that the red is kind of staying a little further back. This was the original versus the second one. And you can see here that now we have changed from the red that you see here at the upper top. This was the original, and this is with the baffle here. You can see how we've changed it. Sorry, whoops, I went forward. It gives us a more planar distribution as the air flows from the 3 plumes. So now we have 3 plumes coming across versus the original, which we had 2, which the air was pushing across this one area here at the top and the right. Now we have air pushing through the center and a little more even distribution across the entire surface area. Goal met. All right. So the baffle works. What does the dampener do for us? All right, let's add that variable in. So what you can see here, here's a study. We did the baffle fully open. We're looking at the cubic feet per minute of 80.81 cubic feet per minute wide open. And when we shut the baffle down, this makes sense, right? There's nowhere for the air to go except for this tiny little sliver of a crescent moon. And we dramatically slowed down the cubic feet per minute from 80 to 19.37. So let's take a look at what happens here. We ran the smoker study with no baffle fully open, and the different degrees, 16, 30, 45, and 15. And we can kind of see that these are the hot spots. And as we shut the baffle down, the temperature in the cook chamber increases. Makes sense, right? There's nowhere for the air to go, so the air inside the chamber is going to increase. And you'll notice here on this last one how red hot it's getting. We said, all right. And then again, we're starting to look at our bulk average temperature when the degrees are open. When it's open, the temperatures are cooler. More air is flowing through it. As we shut the dampener down, the bulk average, again, the difference in that entire cook quadrant, so to speak, is increasing. Again, there's nowhere for the air to go, so it's got to go up, right? All right, so with the baffle, with the dampener open to close, and with the firebox temperature set at a consistent 1500, let's take a look at what happens now to our plots. So these are the plots now that we're looking at. If you'll remember just a moment ago, we were looking at, this is what the no baffle fully open. And now we're starting to look at what this cook chamber looks like now. We're starting to distribute the heat around the perimeter. Again, a little bit of a bulk average chart. You can see that about 60 degrees, it got at its hottest, oddly enough, which was kind of interesting to us. And so that's where we're at on the study. And so our study has led us to believe that we can make significant design changes to the current smoker designs that are on the market to basically allow you to use the entire cook chamber. If you go down to most of the barbecues like Franklin's Barbecue or Black's Barbecue, kind of the famous ones here, you'll notice that they don't use that front quadrant of their smoker. So our goal is to figure out a way so that us, the backyard smokers, and then the professionals can figure out a way to utilize that cook chamber. There's a company here in town that's selling brisket for $37 a pound. That's kind of crazy. But when you figure he has 5 pits and all of them are not using that front chamber, he can put 6 briskets, 14 pounds each. He's running 360 days a year. It's a $4.5 million revenue loss because they're not using that front cook chamber. And so hopefully we can come up with a design that allows everybody to utilize that, and that's more brisket for all of us. So, Wes, I'm gonna turn it over to you.
All right. Hey, I'm ready to go to lunch now.
Let's see. I need to stop sharing somehow.
All right.
I'm gonna change presenter. Hold on, and I'm gonna change it to you.
Great. Thank you for letting me know.
Looks good, Wes.
Okay, let me move this out of the way here. So, thanks, Dave, for taking the time to illustrate SIM analysis there and letting everybody see some design principles and engineering techniques on that. So Dave introduced me earlier. I'll do it again myself. My name's Wes McMurtrey. I'm an AE with GoEngineer from the Tulsa office. So I work primarily in the Oklahoma region, and so I'm your local go-to guy if you have questions or have things that you want to discuss about SOLIDWORKS technical on the technical side, and that's me. And I'm glad to be here today. I'm glad you took the time to show up and listen to what we have to offer. And so let me go ahead and get started here. So I've got a slide here. The first thing I'm going to talk about or show a couple different instances of SOLIDWORKS CAM. And SOLIDWORKS CAM is available to anyone that is on script And today I'm going to show you things that you can do even on the most basic package of SOLIDWORKS CAM, which doesn't cost you $0. It's the milling package, and making milling parts is what we're going to do. We're going to do one that would one part that would kind of represent a plasma cutter, a water jet, or a laser. And then the other part there, you can kind of see we're going to use just some milling operations to take the part and finish it out and get it ready for manufacturing. And then after that, we're going to take a quick look at the Visualize tool. So if you ever need photo renderings, it's a nice tool to clean up product images, like I mentioned earlier, and Dave mentioned earlier. And you know, even work instructions, those sorts of things, just gives the organization a more professional touch. And it's not a hard tool at all to learn. But we're going to go ahead and, with all that said, I'm going to go ahead and get my screen started here. And I should have SOLIDWORKS up on the screen, and if I don't, someone can poke me. And so my model's pretty much is exactly the same as Dave's model. What he has shown, I have added a side table in sheet metal out to the side there. That's we're not going to focus on that right now. The first thing I really wanted to show was being able to open up a part in SOLIDWORKS, insert that part into a new part, and then use that to create a CAM part. So I'm going to open up this assembly, or just open up the part. Dave was mentioned earlier. Here's my multi-bodied part that I have that I can use to start pulling parts off of this to get ready to bring into the CAM side of the software. So let's go ahead and get started here. So the first thing I'm going to look at is this grate down here at the bottom, and I'm going to be able to find that actual body in my cut list. So when I go up to my cut list and expand that, I'm going to go all the way to the bottom, and here Dave was great enough here to name everything, which makes everything super handy, super helpful, super easy to find. So it's called grate under cooker pattern. So I'm going to select that and then right click on that. And what I want to do is go ahead and insert that into a new part. And we'll say okay to that. That's not a problem. So we're going to insert it into a new part. We'll say okay there. And from here, we'll go ahead and we're going to save it as, and we'll just call it smoker grate undercooker, and I'll just call it V1. And we'll say save to that. So now I have inserted a new part as a standalone, or it still has references back to that original part, but now I can go ahead and start working on this in the CAM side of stuff. So SOLIDWORKS CAM can be found if you've never seen it before or didn't know it exists. If you go to your options, your gear up here, and go to options and then add-ins, it's going to be found in the add-ins area, even though it's technically not an add-in. SOLIDWORKS CAM and CAMWorks have partnered together to fully integrate the SOLIDWORKS CAM into SOLIDWORKS itself. So, but we still need to create and select the add-in if we want to use that. So no big deal. Just check if you never got into that. Let me get a drink real quick. And then go ahead and say okay to that, and then give it a few seconds. Of course, mine was already pulled up. And you'll see these 3 tabs. We have 3 tabs out here now that control all the aspects of well, not all the aspects, all the programming side of it. We have other things that other aspects of SOLIDWORKS CAM, but this is what's considered the feature manager for the CAM side, and it's really I call it I think of it as just a 1, 2, 3 approach. I know that I need a machine to do my work. I know I need stock, and I know I need a coordinate system for my machine to know where the heck it's actually going to take off with, or take off from, and start making chips fly or sparks fly. So the first thing I'm going to do is go ahead and double click on Machine Mill. And this brings up my machine property manager. I have several tabs up here. Don't let that stress you out. There's really only a few things with a simple mill that you're going to be looking at. The first one is that we're just going to select mill, inch. I'll go ahead and click on select. Even though it was selected, I just always kind of have it. I want to take a look at my tool crib. Now this tool crib is a built-in, made for, already included tool crib with SOLIDWORKS CAM. So it comes preloaded with thousands and thousands of tools, machine parameters, the sorts of things that can get you quickly into the ballpark and start programming as soon as possible. So I'm going to go ahead and leave this set to my tool crib 2, and we'll take a quick look at our post processor here, and that looks fine to me. We're going to use this as a kind of a default 3-axis tutorial post, and the rest of these are okay. We don't need to do any rotary axis or tilt axis. We're just going to do a simple. Actually, just want to do a simple 2-axis part here because we're going to consider this our plasma cut. So I just about forgot. I was selecting mill inch, but I've got a machine set up that would be more like a setup for a plasma, laser, or a water jet. So I'm going to double click it, and then we'll go to tool crib now. And this time, under the machines that I have now selected, I'm going to go ahead and go to tool crib, and under my custom tool library that I've created, I have one single tool in there, and I'm leaving it, just calling it an end mill. You can rename any of this that you want. You can see here that my end mill is going to be just over 15 thousandths of an inch in diameter there. So that might replicate a laser or a plasma, give or take a little bit there. So we'll go ahead and make sure that we get this tool crib priority, and we're going to go ahead and say use tool crib only. And this will force the machine to only use this tool regardless of what may be coming up. If I turn this off, it may go out and say, I can find a better tool for you, but I don't necessarily want that in this case. So we'll go ahead and say okay to this. So now we have our machine set up, and the next we'll go ahead and look at our stock manager. And we have several options. We're going to leave this set to bounding box because this is literally all I need for this particular part. So it's literally just looking at the length and width and the depth or the thickness of our material there, and encompassing that, and we leave that set there, and I say, okay, that has now become our stock. Now, if we need to increase the size, if we're going to take some off the sides of our part, you can do that as well. If I need some on the X and Y. Also, if I need to do both on both sides, I can just simply select that. But we're going to leave all this set to 0. We don't need, in this particular part, we're not going to be shaving anything off the sides. And now our stock is set up. So that was step number 2. And now, of course, we need a coordinate system. That's step number 3. We normally recommend setting up a SOLIDWORKS work coordinate system, but for a pretty basic part like this, and to reduce a little bit of setup time here, I'm just going to use the part bounding box vertex. And what that does is allows me to, when I select that, it lets me come out and select different areas of my stock. So each of these little balls, these gray balls that we see here, are selectable. So you can see there now, I've selected my upper left-hand corner, at least what I'm calling that upper left-hand corner. It just depends on how it's really rotated. But this is me getting ready to set up my work coordinate system that the machine is going to use to actually find this corner. So I don't necessarily want Z going down this direction, so I'm going to select my axis function here, and then I'm going to come out and select on this edge. And this edge is going to force or tell the Z-axis to follow either up or down in that direction, but I'm going to flip the direction, and that looks a little more like maybe that's what I want. So I've got X in that direction, Y going up, and Z also going up and down to my part. So we'll go ahead and say okay to that. So that was the 1, 2, 3, or what I call 1, 2, 3 of getting everything ready to start creating operations, feature operations and toolpaths. So what I'll do next is under coordinate system, I'm going to right click on that, and we'll go to mill part setup. So mill part setup, it's assuming it's using a default front plane, which is the SOLIDWORKS front plane. I can see this little circle with the crosshairs and an arrow. That's indicating from which direction the spindle or the machine tool is going to travel to get to our part. So I probably don't want it going in that direction. So I'll just simply select the top face of my part, and this will tell the machine to bring whatever it is down in this direction to start work. And all of that looks okay, and we'll say okay. So we got our first mill part set up now. So what do I do next? I have to create an operation or toolpath. So to get started on that, I'll right click on mill part setup, and I'll use a 2.5, what we call a 2.5 axis feature. And we'll go, and these are going to be, I'm not going to select pocket because pocket will basically create a toolpath that mills out all the material. I don't need to do that with a plasma cutter, right? I'm just going to use a slot function. From there, we'll go ahead, and this outer loop, if that's selected, that's going to basically cut the outside portion of the part, at least the way it's set up right now. But I'm going to go ahead and use my inner loops. What that'll do is going to go in and look at all of these diamonds, and as I call them diamonds, hex patterns or check patterns. And for my selected entities, I'm just going to simply select the face. And it's going to take a second here to go through and look at and analyze this entire model. There's actually a lot going on there. So now we see all the different inner loops. We can see they're all highlighted, and that's what I want to see. Green and blue, that looks pretty good to me. Now under in condition, this is exactly like it sounds. It's just we're giving it a condition to go through the part at a certain depth. What I'm going to do first is I'm going to select my cutting strategy that I've already named plasma. And when I select plasma, it goes ahead and gives me what I'm looking for there. As far as the tool diameter, kind of slipped away on me before I could get to it. And so what we're really looking for, I already know that the part's 1/4 inch thick, so I'll just leave it set to blind, and we'll make this 0.26 inches deep, just a little bit past the bottom face of our material there. And let's go ahead and say okay to that. And doing that, let's give it a second here. So now we have created a feature that we can go ahead and it's recognized this as a rectangular slot group. And what we'll do next is we'll right click on this, and we will go into the next step of this is generate the operation plan. So our operation plan is actually the precursor for our toolpath that's going to be created. So now it happens really fast. You really don't notice, but we went from the feature tree over to the operation tree. That's where we're at now. So now we have a toolpath. We don't quite yet have a toolpath because I haven't generated my toolpath. I'm going to go to my SOLIDWORKS CAM tab so you can see all the different tab or buttons for the SOLIDWORKS CAM. Sorry about that. So what I can do is before I do anything, I can go in and double click on that, and it's going to pull up our operation parameters. So this goes and lets me decide, do I want to use this tool? Do I want to change things about this strategy or these operations that we're about to do? It lets me change the holder, and that holder, that's kind of big, so I'm going to change this or just leave it set to basic, and I'm going to dial all of this down quite a bit, just manually here. And rather than reaching up and clicking on the keyboard, I'm just using these arrows to kind of drive everything here. And I'll drive my protrusion because I know I'm going to go at least 0.26 inches deep into the material. So that'll get a little baby tool out there to actually make the cut. And I'm going to change this flute length to 0.3 and just to make that stand out, and overall length is fine. And let's go ahead and look at our contour. I want to look at what's going to happen when I get ready to cut this. So right now I've got my cut set, my first cut set to 0.26 and my max cut set to 0.26. I'm just going to set that to 0. And I'll leave this first cut set. And this should, unless I got this sideways here, when I go to preview this now, I'll go ahead and look at this and say, yeah, that's exactly what I want. So these options that we just changed there basically control how many tool paths it's going to take until it gets to the bottom. Well, with a plasma or laser, I'm probably not going to be making multiple passes to get to the bottom, right? I'll probably just do that with one. So we'll do that all in one there. And so we have our lead angle or lead in and out angles there. If we need to change that, we can go in, and from this window, we'll go to lead in. Right now, it's set to 1/8 of an inch. If I would like for that to be larger, just a matter of changing that again and changing. So fully functional there. So if we need a larger arc radius, it's set to 10% now. Maybe I want that to be a little bit smoother, or quite a bit smoother as that laser enters that cutting area there. So we won't leave quite as bad a witness spark there or a burn mark. And from here, everything else is fine. So we'll go ahead and say okay to what we have. So we have now created a toolpath that we can go now and take a look at under the simulation. So let's go simulate this real quick. And I'm going to use turbo mode just to make this a little quicker. We'll go ahead and click on the run button here. And you see that was pretty quick. It take about a second, and you can see now I looked through my part. You can see our lead-in cuts. I have to zoom in here a little bit. So now we have a part, our first part for our grill. So that, took literally just a few minutes. And of course, as you get more and more familiar with CamWorks, this would probably take someone with some experience just a few, maybe 2 to 3 minutes to get this out, post-process and out to a machine there. So let me go ahead and save this, and then we will go to our next part. And this will be this next portion will be a little bit of wash and repeat what we just did, and make sure I have the solid part open. This time we're going to use the mill functioning a little more, and a few more of the built-in processes for making pockets, roughing, those sorts of things, instead of just a kind of a generic plasma toolpath. So what I'm going to do is we've got our part open already, and then I'm going to select it so I can kind of find which cut list item that is, and I can see it there. And it's called the GoEngineer door logo. So I'm going to right-click there, and we'll do the same as before. We'll insert into a new part, and we'll go ahead and say OK to that. And now we have, got to give it a name first, and we'll say save to that. So now I have my smoker door that's getting ready to be milled out and milled, and then the back side of it also pocketed out as well. So here we go. We'll go ahead and kind of like before, the 1, 2, 3. I'm going to go back in, look at machine just to double check. Okay, it already defaulted to mill inch. That's what I'm looking for. Tool crib, it's fine. And we're going to look at our post processor. That's kind of what I'm hoping to see there. And we should be able to say all right to that. Same goes as before. When we take a look at our stock manager, we're going to select the bounding box method. And you can see there, our bounding box is essentially filling in the volume of our part there. We can say okay at this point. And once again, we will go with the part bounding box vertex, and we'll select an area. And same as before, I'm going to have to select my Z axis, but I don't necessarily want to go in that direction. Maybe I do, I don't know. Every machine's different, right? So, but X, Y, and Z, we'll leave it set to that now, and we'll say okay. All right. Dave, am I making you dizzy? I'm doing a lot of zooming in and rotating. Dave may be offline right now.
Sorry, I had my mic muted there. But no, this is awesome. Keep rolling, brother.
Cool. And so we'll go back to mill part setup. You can notice here our front plane is kind of the default setting because it doesn't know yet where the machine's coming from or the spindle travel is. So top face selected, and our arrows pointing down into the part. That's what we want. And for this particular model, we've got our mill part setup, our first setup going now. So I'm going to right click there, and we'll go to 2.5 feature, or 2.5 axis feature, sorry. And instead of slot, I'm going to use a pocket type strategy to mill out all of these. Now this, technically, you'd probably really want to use a plasma or laser or water jet to do this part. But I'm crazy like that. I'm going to mill this out with a big old fat end mill. and we'll take a look at it after we're done. And we're going to select pocket, and we'll do the same as before, our inner loops, and we'll come out and select that face. Notice before, now our inner loops, everything that can be removed is highlighted. Same as before, our in condition and our toolpath. I'm just going to set this to using a rough strategy. And that can show me there I've got a 1/4 inch end mill that that's going to use. Of course, those strategies can be fully customized to your liking, and that's really the power behind the SOLIDWORKS CAM and CAMWorks, is once you get accustomed to what it is you're doing and what you want to do with your machines, the strategy can be completely customized. So you spend increasingly less and less time programming your parts once those parts are known to the CAM software, and you've made that commitment to develop your own toolpath strategies. It's completely customizable. So this is a default setting. I haven't touched it. Like earlier, I had a plasma strategy. This particular instance, I'm going to use just the fresh out of the box strategy for this particular part. Our travel, since I know this part is a 1/2 inch thick from top to bottom, and I know this pocket is a 1/4 inch thick, so I'm just going to have my end mill go through this material at about maybe 0.28, which should give me about 30 thousandths past the bottom lip or face of what we're going to flip over here in just a second, rough mill out that pocket. And that all looks pretty good. We'll say okay to that as well. And now we can see we have all of these different features that it's found. As I hover down through there, you can kind of see there, it's highlighting each and every one of those. So I've been doing mostly right-clicking and selecting Generate Operation Plan, but all of those buttons are also available right here at the very top row, Command Manager here at the top. So if I just simply click on Generate Operation Plan, I can do it from there as well. And now we have our Generate Toolpath available, and now we can see that these are all of the different toolpaths that it's using. And so let's go ahead and generate our toolpath. So this has created several different operations. These can be combined. It's kind of what is it that you need to do if you don't want to see all of this, and you want to control each one of these exactly. Each one of these what's considered a rough mill pocket. The same, you can come up and right-click on Mill Part Setup and go to Combine Operations. And it's going to take, and I'm just going to select rough mill and say OK. And this literally just combines all of those operations you can see now into one. And then we have a second rough mill due to the fact that this pocket was a little larger than anything else out there, and it decided, hey, I can probably put a 3/8 inch flat end mill in this area here and get most of what I'm looking for there accomplished. But remember, this was just the rough mill strategy, so it didn't go in and find a little baby end mill to get into these areas here. But for today's exercise, what we're doing, that's fine. We're just kind of going through the process and not walking through the weeds and getting too far off the deep end here today. So we have a rough mill. Let me take a look at the passes. That's actually pretty decent. It's just 3 or 4 tool pads down to the bottom, and a rough mill is kind of the same thing. So let's go ahead and finish out this area of our model. So let's go back to our feature tree, and once again we'll right click, and this will be yet again another 2.5 axis feature. And for this particular instance, I'm going to consider this a boss. And all I need to do now for that boss, select that edge, the end condition. I just need to select the face. So that end condition was 2.5 or 1/4 inch. And we will just leave that set to finish. That's fine with me. It is going to go ahead and pre-select a 1/2 inch end mill. And we're going to change that though in just a second, due to the fact that if I left it at 1 or a 1/2 inch end mill, when it comes through and makes its pass through these corners, it's going to leave some material in these corners here. So I don't necessarily want to do that. And I don't want to go do a bunch of other things to make that work. I don't want to use 2 different tools to clean that up. So all I really want is just to make one pass around this thing with one big end mill, or a larger end mill anyhow. So let's go look at saying okay to this. I think everything looks pretty good on that. And once again, with that, I'm going to just right-click this time and say generate the operation plan. And for this particular toolpath, let's go ahead and edit this real quick. Take a look at some of the things. Quick way to change a tool. If you don't want to go to the tool library or the tool crib and add a tool or select a tool, is just to simply come and just make what you have, what the default setting has there, and maybe and a half. It's kind of odd looking in mill, but we're not, like I said, we're not going to get off into the weeds in particulars about in mill design and drill points today. So our type is flat end mill. We'll make sure that that's good. But this, by making this 1.5 inch, I'm guaranteeing, or I'm ensuring that if I look at my preview here, as I come through my model there and I look at this, that corner out there is going to get taken out with that as it makes its way around the periphery of my model there. Our contour, I'm going to change this from percentages to first cut is 0.26. That is 0. I think that'll work. Let's see real quick. So I did a quick preview before I even really generated anything. So I've got it's like a pretty decent lead in started for me, and it should be about right there. That's what I'm looking for. That blue line is my tool path, working its way around the part there. So I'm rapiding in. This is what this red dashed line is indicating. Then a linear feed, then a straight line in, then a slight arc. Of course, that can be adjusted if you need a larger arc. You don't want to leave a little ding on the side of your model there, but that's fine. We know where that's at. We kind of looked at that earlier on the plasma part. And then a red dotted line back up. That's indicating the rapid out motion there. And under the next tab, I don't think I'm really going to get in. I think our lead in looked fine. This is where it's all at. So this is really all of the different tabs that control the feature tool paths and how the machine is going to actually mill or cut or drill or turn your part. This is the operations parameter. And I'm pretty happy with that. So let's go ahead and say okay. All right, so let's do a quick simulation and see what this is going to look like. All right, so back in turbo mode looked like there. Do it one more time. Yeah, so in case you missed it, the turbo mode basically is a quick and efficient way to go through and mill your part out. It bypasses using the tools there. If I go back, we want to see that. I'll click on the tool mode, and then we can actually see the end mill going into the material and making its tool path. So it's a little slower than turbo mode. Of course, turbo mode should be a little faster, right? It's called turbo mode. And as it goes. All right, so there's our part. It's ready to go. Now we're ready for our second setup. So we're going to flip our part over, stick it back in a vise or some clamps or a fixture, and we're going to get the back side of this milled out. So we'll go back and create a new 2-axis feature. This time we're going to use the pocket again, and we'll leave all this set the same. All I need to do is select an edge, and it knows to go ahead and take this as considered as my pocket. And our ink condition, same as before, we just need to simply select the face. Let me X out of this. I just noticed something that I did skip, and before I crash our machine later on this afternoon, I am going to say this is right in SOLIDWORKS. Just deleting something is faster than trying to fix it. Exactly what I'm going to do, because I skipped a step by not creating the mill part setup. So here we go. Everybody makes mistakes, right? Especially on Friday afternoon at 1 o'clock. So, and this is the same as forward selecting the face. You notice now our spindle direction has changed due to the fact that now our part is upside down, or at least flipped 180 from where it was, and we need it to go into that direction. So we're back in business now. So now let's go generate our 2.5 axis feature. Pocket, outer loop, select an edge, and here we go. In condition, up to face is what we're going to use, and we'll just do the same as before. We're going to rough this thing out, And this time it did go ahead and select a 1.5 inch end mill for this particular thing. Just like as before, we can either change our tech DB IDs or do this on the fly once we get to our, and we'll say okay to that. Now we have this feature. If I select on it, we can see that it's highlighted. Back to this, we'll generate our operation plan by right-clicking on that. And then once again, let's go ahead and take a quick look at what this toolpath is going to look like, because I know when I go to rough this out and I go to, where are you hiding that on me? Book feature functions. I don't necessarily want a 1.5 inch end mill going straight down into some steel, right? So let's go ahead and change that. And this, I'm going to change the spiral, and I'm going to make this pretty large. So this radius is 1.5. Pitch, I'll just leave that set there. And let's go preview this now. So rather than just going down and pretending this thing's a drill bit, now we can come in, start spiraling our way down into our material, then out, and start working our way around the part there. So multiple ways to plunge into a part, get things rolling, and let's go look at our roughing there, final cut. Let's see, we're going to set that back. We'll just make one cut there. Let's preview that real quick. Should just be one toolpath, and it is. We're not going to be too concerned about cleaning up these corners here. This is not the mechanical make side of the part. This is. So we did machine this side out to a specification. So when this thing opens and closes, we should be good. And all right, so we've got our pocket out, and we'll go ahead and say okay to that. Now, let's go back to simulate our part. Let me get it rotated. I'm even getting dizzy now, Dave. So let's get going here. And for this, we'll use the tool mode so we can kind of see what's going on. One more time, take a quick look at what we just accomplished here. So there's our first setup running, our end mill going through, making the pockets, cutting the pockets out. And here in just a second, the setup will flip over and cut the other side of the part there. Now we can see our part is pretty much complete there. And go ahead and say okay to this, and we'll save. I'm going to close these out. Save all. All right, so I'm going to go back into my assembly. No, not yet. We'll close this one out too. So with Visualize, this is an area where you can do a lot of work up front while you're still in SOLIDWORKS as far as preparing your model to create appearances. And Dave has done an outstanding job on preparing this model with what's called an appearance called black spray paint. And I have actually intentionally put a table on here with just a slightly different variation of black spray paint. You notice it's kind of a little different color than the rest of the model, but we're gonna change that once we get into SOLIDWORKS Visualize. And the thing that I wanted to talk a little bit about is if we decided that this door, we were just going to press on or use clips to insert the lettering, or made this more of a placard where it was just more of a production type set, using high temp plastic or whatever, maybe some cast alloy or something to attach to this thing here. We may decide, hey, you know what, we don't want it to necessarily be the same color as the rest of the assembly. Maybe we want this to be a color that represents our company. And so in the last couple of years, SOLIDWORKS has created a way to go out and select. If I go in here, I'm going to go look for this this particular area here. Well, let's see, the logo. That's what I'm looking for. What I'm going to do is I'm going to look at the Boss Extrude, which is what Dave has created here to extrude the GoEngineer logo and the symbol for GoEngineer. And what I'm going to do is I'm let me go ahead and get this ready to work on him. I'm going to pull this kind of halfway on, halfway off the screen here. And so we can kind of see what I'm getting ready to do. Can everybody see this down here, the green pointer that I have? Dave, can you see that, the green logo?
Yes, sir. It looks good.
Okay. So what I want to do is, if I know this is going to end up being a separate component from the rest of my assembly, and it's not going to be powder coated or spray painted, I can go in and we're going to change the appearance of that boss extrude. And one of the cool things I've done in the last few years is allow you to go out and use your eyedropper. I drag that out and hover above anything outside of any bitmap, JPEG, websites, you name it. If it's on your computer and it has a color, you can select on that and you'll get the exact color you're looking for there, which can be a giant time saver if you've got a vendor that's demanding that you use the exact Pantone color and they're not even giving you the Pantone color. They don't even know what it is. And it allows you to at least go out to their website and use what they're using. So, and we can say okay to that. I just wanted to make a quick change there on that. And really, when using SOLIDWORKS Visualize, the more detail, the better. And Dave's done a great job adding a lot of detail on this model. And so really all I'm going to do next is go straight into, maximize the screen. And let me go take a look at our PowerPoint here. And our next slide was the Visualize. So this is sort of what we're going to end up with. This was just a quick render. Literally, it takes very little effort. You can go from product images, especially for web pages or internal documents, from just some decent quality to high quality. So this just literally took a few, less than a minute to generate, and that's what we're going to show today. Is that you get back in here. So I've got my model. What I'm going to do is go in and just enter the Visualize tab. It's open now. I'm going to look at my Export Simple. That's all I need to do. And once that starts rolling, I will go in. I actually already have Visualize open, so I need to go here. And here we go. So I just exported this model into Visualize. And I'm using pretty much straight out of the box SOLIDWORKS Visualize settings. So this is rotating it, manipulating it, operates exactly as if you were in SOLIDWORKS. Your middle wheel rotates, zoom in and out with your wheel, can pan by pressing Control. So let me set this right now. My setting quality is set to fast, which is a pretty decent setting. But while you're working on a Visualize product, you probably just want to leave this set to preview. And that'll keep your graphics card and your CPU from getting lit up. You can probably hear my fan roaring right now off my laptop. So, but now we're back down. You don't get as much detail, but it at least allows you to rotate your part around without too much lag. So let's take a quick look at what we have here. I'll do the kind of the 1, 2, 3 thing with what we're seeing here, what is going on in Visualize. What we have, like I mentioned earlier, my table is slightly different variant of spray paint or paint than the original scene here. So what we have here are, if I click on that, this is the body or the item that has that appearance. Come here and select on this. You notice the rest of the assembly is now this black spray paint. So if I just made a mistake and I really want everything to be black spray paint, I can come out and hover above my model there. Unless I missed my model there, I may have. I still have that highlighted. And it's hard to really tell in this setting here, but yeah, I may have changed it. But to make it more significant, if I wanted to do, per se, brushed zinc, say I'm going to make a stainless or zinc plated table there, just a matter of dragging those appearances off onto the item that I want the appearance to be changed on. So those need to be separate components to behave like that. You notice as when I clicked on this, the entire unit is outlined now, or most of the assembly. And that's due to the fact that all of this has been created as a multi-body part there. I'm just going to go ahead and change that back to just kind of keep it simple for today. So that was one. That was the appearances. Next up, we can look at scenes. And right now I have a couple of different scenes or environments. So if I click on my what's called the high contrast ramp, I get a little brighter, shinier look to my render. I double click on plain white. It's a little more subdued. So there are literally hundreds, if not thousands, of environments for creating the lighting for your studio. I liken this to this is the lighting in a photographer's studio, and what's called a backplate is what you see here, the gray. So this would be like a drop cloth that someone may have in their photo studio that's controlling. These two are interacting with one another to control how the lighting's interacting with one another. So these are environments, backplates, and then could also control the lighting as well. So if you want to change the direction of lighting or add lighting, the type of lighting, all of that can be done from this tab here. So this is all controlling the scene. And let's take a look at it. Enabled, visible. So we can kind of see it's throwing a pretty harsh shadow down away from my model there. If I need to change that, we can go in and add, excuse me, the brightness. We want to make that maybe a little less bright. Maybe that looks, and we want to go into changing the shading. So maybe it's later in the afternoon, or you're going to set this into an actual photo for presentation. You need the shadow to match up with an existing photo. This will help add to the realism. So that looks fine to me. And then third, we'll look at cameras. And just as it sounds, we can look at the longitude of our camera, latitude, the twist. I don't want to change that because that literally twists the camera. We'll just leave that set to, did I actually move it? I think I did, didn't I? Maybe not. Oh, it's fine. Height for floor. These are all things that can be changed or altered. We have, let's take a quick look there. There's nothing we're going to do here because this has some motion blur functionality. We're not going to put anything in motion. And we'll leave the rest of that set alone. So that's a quick rundown of Visualize. You see there, I really didn't have to change anything to get a pretty decent render right off the bat. I just simply exported my model into Visualize, and it gave me a fairly decent model there. So if I go back in here and we'll look at quality, and we'll bump this up. This is going to take a few seconds there as it starts to run passes. You see down here at the bottom of your screen, it's making passes. I've got it set to 100. I don't know what the ideal exact pass is, but I know 1,000 is not anything to consider too much, and even more than that. It just depends on what level of detail are you wanting to show in your rendering. Let's let that run for just a few more seconds there, and then.
That's super cool, Wes. I like how you can use the dropper, the teardropper, to apply the color, and that pushes into Visualize, and you change the shadowing. I like that.
It's added. I've done some photo work in the past, and it was always I've done this where you had to add the right color, and there was no way to just go out and match that. You had to actually copy the image before they had this functionality, and then save it as a PS2 file and do a bunch of work in it in Photo View 360 before you could even get to this point. And so that saved a lot of trouble. All right, so say I want to change let's go back to our scenes. Let's say I want to add a different backplate. Let's just change one thing on here before we're ready to wrap this up. Say I want a new backplate. And I downloaded a couple pictures off the internet, and they're not super great, but I'm going to use this one as a backplate. exactly what it sounds like. So I've got a real image or an image of someone's back patio, and now you can see here that. Of course, my 17-year-old says that doesn't look real at all, and I know that it does. But you can see it with some time and without having a 17-year-old lurking behind you, commenting on everything. That with some time and some effort, we've all seen some really beautiful rendering. A lot of times when you think something's real, if it looks too good, it's probably a render, and that's usually the giveaway on things you see in magazines, and automotive commercials, and ads that you see in magazines. A lot of that has been rendered by someone that has spent a lot of time getting that just right. So, so that was Visualize. That's really about this. I just want to do a quick rundown of Visualize, and there's tons of other stuff, but that's your kind of your CAM 1, 2, 3, and your Visualize 1, 2, 3 on a Friday afternoon. And let me go back real quick here under Visualize, and then make sure
you can see that. Okay, Wes.
Yeah, you're good.
Okay, and then we want to stay in touch with you. So please sign up for our newsletter. You will get quite a few emails telling you about what new content, new videos. I believe Kyle is the representative for most of you, so helps you stay in touch with Kyle, and he can let you know what upcoming events, things like that, as well as Dina. And then the SOLIDWORKS training. So today you've seen some multi-body modeling, you've seen a little bit of sheet metal, you've seen a little bit of Weldments, and you've seen some sim, and you've seen some CAM, and Visualize. And we have all those training available for you. And that's our jobs, one of our jobs, Wes and I, to do the training for these classes. So go up to our website and register for classes. We are starting to have some in person. Most of them are still virtual, but we also have online classes where you can do it with a group or self-paced. So sign up at our training link on our new website at GoEngineer.com. And then check out our YouTube library. We have over 3,000 videos up there just to help you with specific commands and needs inside of SOLIDWORKS and SOLIDWORKS related products, such as PDM or I don't know, Visualize, whatever the case may be, or 3D scanning. They're all there. And you can follow us on social media, LinkedIn, Facebook, Instagram, and Twitter, of course. And this is, we appreciate everybody being here today. Here's our contact information. Wesley, of course, being out of the Tulsa office, myself, David, out of the Austin office. Our LinkedIn links are here if you want to screenshot it or do something like that. There's also our emails. If you want to email us directly, we'd love to hear from you as well. And with that, I think that pretty much wraps it up, Wes.
Yeah, me too. I'm glad to see everyone here. Hope everybody has a great weekend. And we look forward to talking to you soon and working with you on anything that you may need. So, Dave, great job.
Thank you, Wes. That was awesome. I learn something every time I watch the CAM. It's just fascinating. I love watching the CAM stuff, especially the kind of the simulation of the CAM.
Yeah.
And when you run the tool paths, that I just absolutely love it. But what it does to me as a designer, it helps me reinforce when I'm designing something like, hey, you know, like we kind of touched on it earlier, I can put a fillet on anything, but if I don't have the tool for it, what does it really do for you? You know?
Just like the back side of that door, I can't cut a square corner with an end mill.
Yeah. Yep.
Those are, you know, those are things that you'll, you know, as a designer, depending on what you're in, that's how we all learn, right? Communication.
Yep. That's it. And, you know, just understanding the design intent of the product, right?
Right.
And that was the first thing we talked about. Can I make it adjustable and can I make it manufacturable? And is the design valid? So we kind of looked at from a concept to, hey, I'm actually machined the parts to now I've got a product that I've run and visualized that I can start making my website from these images. So kind of a soup to nuts there.
Yeah.
Cool. Super cool.
Well, any questions that we haven't answered today, if we see them later on, we'll get back to you and get those answered. I think I answered a few during the webinar, and hopefully those were satisfactory. not, we will get back to you on that soon. So I'm about ready to go ahead and say okay to this.
All right. All right. Thank you everyone for attending. Bye-bye.
Bye-bye.